Hey, welcome back to our LeetCode series with a focus on Facebook interview questions. Today we'll be targeting two questions. The first one is generate parentheses, and the second one is called merge K sorted lists, which is a bit tricky. It's a hard question, but I've done it before, and hopefully we'll be able to solve it pretty quickly. So here we go. Generate parentheses. Given in pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So what that means is that the number of open parentheses on the left never exceeds the number of right parentheses on the right. So here we have 3 on the left, 3 on the right, 2 on the left minus 1. So then there's 1 on the left, 2 on the left again, then there's 2 open. So the number of open parentheses must exceed the number of closed parentheses at all times, more or less, and they have to be in the right order. So what we do here is just another classic backtracking problem where we will create a stack and then merge that stack into the output. It's recursive, and yeah, let's go ahead and jump in. So here we'll have our output. Let our output equal what? Empty array. And then here we'll have our stack again, also another empty array. And then what we want to do is call a for loop. And this for loop will have how many opens and how many closes we have remaining. So not for loop, a helper function, sorry. So here we go. We'll do our function. So a function helper, and inside we'll pass open, which will automatically be at in, and we'll also have close, which will automatically be at in. So we have our open and our close of value in. So basically what we want to do is say if open is equal to 0 and close is equal to 0. What we want to do is output our answer to the stack, or output our stack to the, push our stack to the output, sorry. So then we say output.push, and then in here, we'll say stack.join because we're pushing a string. And then what we want to do is return. Pretty straightforward. And then down here, next up what we want to do is call our helper. So our first case would be an open. So this will be another if statement. So if our open is greater than 0, so if we have any opens remaining, what we want to do is say output.push, and then what are we pushing? We're pushing in open parentheses. But we're not pushing it to our output, we're pushing it to our stack. And then what we do here is call helper, where open minus 1, because we used 1 open and we had the same number of closed. And then we want to revert our stack back to the original, so we'll pop it off. And then next up we say if our close is greater than 0, but we also have to have another one, and close is greater than our open. So there always has to be more open than there are more closed available than opens available, because this means that we've used more opens, which means we can use our close. If there are equal number, then there would be no match for our close. So in that case, what we want to do is say stack.push, and we're going to be pushing the closing parentheses. And then we call our helper again, where open is still open and close is minus 1. So we're decrementing our close, and then at the end, what we want to do is stack.pop and remove that. And then, yeah, that goes through the entirety of this. And then what we do after that, we call our helper, and then we return our output. So pretty straightforward. Let's run it. Does it work? It does work, awesome. Then we'll submit it. Does it submit? Does pass all of them. We're better than 81% of other people, so good job us. And a little bit below average on our memory, but that's okay. that is how it goes. Our next one. Okay, so here we go. We have k sorted lists. So you're given an array of k linked lists. Each linked list is sorted in ascending order. Okay. Merge all the linked lists into one sorted linked list and return it. Okay. Pretty straightforward, but a little bit complicated. How do we handle an unknown number of linked lists? Well, we've done a similar question where we didn't know the exact number, but basically what I want to do is say first up, we need to check if our list.length is less than 1. If it is, then we return our null value. And then we also say if list.length is equal to 1, so there's only one list, then what we do is return list at 0, because that would already be our sorted list. And then from there, we can implement our logic. So first, what I want to do is create an array. And this array will hold all of these linked list pointers. So let our pointers equal an array of size, what? List.length. Okay, that is our first step. And then our next step would be to fill this pointer array with our lists. So here we'll say for let I equal 0, I is less than list.length, I is incremented. What we want to do is say that pointers at I is equal to our lists at I. So we're basically making a bunch of pointers in here, grabbing a bunch of pointers, and we're taking them from our original list that we're given. Next, we've done this before, is I always love to create sorry about that. I always love to create a sentinel node, which is just the node at the very beginning, which is a new list node. And then, of course, we'll also have our current pointer. So let cur equal our sentinel. So we're going to be moving our cur along as we go through. And then also what I want to do is keep track of how many valid lists I still have left. So basically every time I reach the end of a list, I need to increment it. And then once we reach a length, the length of the list, we know that we've gone through every list item. So here we'll say let our null count equal 0. We'll start it at 0 because none of them are null at the time. And then here we say while our null count is less than our list.length. This is where we go through and try and get the logic to do what we want it to do. So we are putting them in ascending order, so we need to find the minimum value. So let our min value equal infinity. Infinity is the largest number, the largest number that we have access to. So every number that we come across will be less than infinity. And then we also need to figure out the index of the pointer that this min value is associated with. So let our index equal -1. I'll keep it at -1 for now, and then you'll see why. And then from here, what we want to do is loop through all of these pointers. Okay, so first up we'll say for let I equal 0, I is less than pointers dot length, I is incremented. Then here we say if there's no pointers at I, which means it's a null value, we want to just continue. We don't need to check the rest of the logic. And then here we do, we need to see if the pointer value is less than our min value. So if pointers at I dot value is less than our current min value, what we want to do is say that our min is now equal to pointers at I dot value. And here we move our index is now equal to the I. So that is the index of the current minimum value. Then here we say if our index is triple equal to -1, that means there was no value that we went through, which should have been caught by this part here, but I'm just going to keep it here just to be safe. What we're going to do is break. Else what we want to do is say that our cur.next is equal to a new list node with our minimum value, and our cur is now equal to cur.next. Yeah, so I'm just creating a new list node with that value. And then of course we have pointers at index is now equal to pointers at index dot next. So we're just moving ahead in our linked list. And then here we say if, this is an if check, if our pointers at index is equal to null, so that means we have broken out, what we want to do is increase our null count. Null count is incremented. And then from there we just return our sentinel.next. Yeah, pretty straightforward. The only tricky part is creating an array of these pointers and then going through them. Hard problems are just easy problems put together, or medium problems stacked on top of each other. So let's go ahead and run it. Please work. It does work, great. Get the right output, and then just submitting it. Get our test suite. And what do we get? We are terrible in runtime. That's okay, but our memory is pretty good. Anyways, that's how I would solve it. Anyways, thank you guys so much. Have a great day.